Hello, and welcome to the Weed Reader YouTube channel. Semi-informal readings of cannabis-related articles, magazines, published studies, grow books, and more. We will be launching a website in the coming weeks offering member-only content, including the Audiobook of the Month Club, and much more. So more announcements are to come as we approach the launch date. Stay tuned. Also follow us on Facebook and Instagram for channel and website updates. So here we go, comparing various water culture hydroponics systems. Water culture hydroponics is one of the fastest growing segments of hydroponics, but there are a number of factors to consider when choosing a system. Water culture expert Frank Rausher goes deep into explaining the differences to help determine which system may best suit your needs. Though the history of hydroponics goes back to the Hanging Gardens of Babylon around 500 BC, this soilless plant growing technique was advanced by a number of distinguished individuals including Francis Bacon and Willem Knott. In 1929, a man named Willem Garrick at UC Berkeley created a more modern example, water culture hydroponics. This hydroponic method goes without media at all, simply immersing root systems into water with nutrients and added oxygen. Understanding water culture systems. Recirculating deep water culture, RDWC, static solution culture, and deep water culture, DWC, are all hydroponic systems classified as water culture. Within the RDWC group, there are a few primary recirculating systems: nutrient film technique, NFT, top feeding, and underflow RDWC systems. Static solution and DWC systems are similar to each other but differ in key ways. Standard DWC uses a mesh pot to contain the roots and aggressive aeration of the nutrient water, but static solution does not require these techniques. Basic static solution systems are mostly used by hobbyists growing plants that do fine with minimal oxygen in the water. Take the betta fish in a tank with a peace lily as an example. When the nutrient water can be recirculated and shared between larger quantities of plants, it is conveniently possible to control nutrient and oxygen levels for the whole crop. If each grow bucket is separate from the others for the crop, on the other hand, maintenance can be cumbersome, especially when there are a large number of plants. In standard DWC, each grow bucket is separate. This is primarily why more deep water culture systems are set up as RDWC. Nutrient film technique is an RDWC method where the tubing channel or trays holding the nutrient water is sloped about 2.5% drop and the water is pumped at a moderate rate of around 0.3 gallons per minute so that the water runs across the roots at a very slight depth. Obviously, the feed rate and slope would be adjusted according to the thickness of the roots. This still leaves us with top feeding and underflow recirculating systems as well as NFT systems to look at. In a top feeding system such as Hydroponics, the recirculated nutrient and oxygenated water is initially fed to the top of the root system. This is most often done with seedlings and younger plants whose roots do not yet extend deeply, and therefore there is a desire to have the heaviest concentration of oxygen at the surface. As these plants mature, the roots will grow and search for additional water and nutrient. Usually within a couple weeks, they will become large enough to reach the reservoir and gain access to that larger source. So top feeding would be less advantageous. Often there is a desire to recirculate nutrient water, though the input is not needed at the top as with more mature plants. The water is then infused at the bottom of the grow pots. This is known as underflow systems. There are several ways to connect this oxygen-rich water to multiple mesh pots. The size of the mesh pots holding the plant's roots will determine whether that pot can be placed in a 4-inch PVC tube or require a grow bucket. The large PVC tube can be used as the underflow connector with no need for a bucket when the smaller mesh pot size is sufficient for the type of plant to be grown. Buckets with underflow connector tubing are needed for larger plants. Production advantages with these water culture systems. It is due to the high concentration of oxygen in the nutrient water that most water culture systems exercise superiority over other systems using grow media. The roots are immersed in and saturated with nutrified and oxygenated water all the time. Properly balanced and maintained RDWC systems will provide maximum yield. With well-oxygenated root systems, the plant can convert sugars and starch into energy for plant vigor. Though photosynthesis occurs only during daylight hours for a plant, respiration occurs and needs to occur all the time. Therefore, it is the recirculating water culture systems that will typically dominate this category. It becomes easier to boost oxygen levels and keep it that way for a large number of plants. Root volume and water uptake requirements are primarily determined by plant transpiration demand, so the amount of light provided is also a major contributor to obtaining greater production. So which of these WC systems would be more productive than the other? It is clear that most static systems are going to be limited in the capacity to provide concentrated amounts of oxygen and nutrient continuously. The NFT and 4-inch PVC recirculating systems are appropriate for smaller plants, and if designed properly are capable of providing just as great a concentration of oxygen and nutrient as the other systems. The single bucket DWC system can also provide these concentrations, but may be cumbersome to maintain proper levels if the large number of plants are involved. The RDWC underflow system would be the choice for the greater number of large mature plants, while the top feeding would be optimum for seedlings and younger plants. With all the DWC systems, except static, a well-designed and properly maintained system will be capable of producing maximum crop yield over basic grow media techniques. Trade-offs for the various types of WC systems. It is difficult to state which system outproduces the other. Success is not really that simple. There are many different viewpoints regarding how to succeed with your crop. Disease is a big concern when the root systems for one plant share the same water as others. This is true for most recirculating grow media systems as well as DWC systems. When using a system where water is shared between several or many plants, greater care must be given towards cleanliness and the observation and interception of root disease. Various pathogens such as Pythium, Fusarium, Phytophthora, Botrytis, and Rhizotonia are common. Knowing and understanding the disease is key to preventing and controlling it. Fusarium is a fungus and thrives in very wet conditions. A symptom plants may exhibit when infested with Fusarium is leaf wilt. An inspection of the roots will confirm their unhealthy nature by displaying a brownish or beige color instead of the white observed on healthy roots. Botrytis, also a fungus, is found nearly everywhere, even the greenhouse and hydroponics, commonly called gray mold. This disease must have some food source before it invades the plants. Often wounded or dying tissue can become this source. Rhizotonia is also a fungus that often is responsible for root and stem rotting. Damping off and leaf blight are two frequently seen symptoms. Pythium is often referred to as water mold because it thrives in watery places. Though sometimes called a fungus, it is not. Rather, it is an humaceae. It's found in poor draining, overwatered fields and greenhouses, as well as hydroponic systems. Phytophthora is also another humaceae like Pythium. When a plant is infected by disease, that plant will not be able to absorb nutrients or water due to extensive dead root tissue. Controlling disease and preventing root rot is vital with DWC systems. Fungicides are generally not effective for short-term applications and do not have much impact on non-fungi infestations. There are a number of effective fungicides and other specified treatments available. Check the reference QR at the end of the article for more information. Phytophthora, not being a fungus, is very difficult to control. Often is detected, it is best to discard and destroy all infected or contaminated plants and then sterilize the entire system before replanting. Maintain a high level of oxygen in the water for WC systems, as this will reduce the opportunity for disease to start. Clean and disinfect between grows and any time possible when a sign of infestation might be visible. Energy costs are higher for continuously recirculating systems. The oxygen levels in DWC drops off rapidly if circulation stops. This is not an issue for most grow media systems. There are also additional pieces of equipment to run, such as the air pump and water chiller, in addition to the water pump. Often, the air infused into the system will warm the nutrient solution and may then require chilling to allow the solution to retain the dissolved oxygen better. Startup and maintenance costs can be higher for WC systems. Leaks can be a catastrophe. To have a reliable system, source and purchase only reputable components and accessories for your WC setup. The more accessories that you incorporate into your system will add to maintenance as well as improve how you can control the grow environment. Space, utilization, and flexibility is always valuable to most every grower. If overall yield is a goal, then you will want to be able to grow more plants in the same space. Being able to relocate plants as needed throughout the grow cycle is important to harvest or maintain the crop you have. Water culture systems can provide excellent space utilization if designed properly, as the focus is optimum production. Modular water culture systems are available and offer the flexibility of being able to relocate or remove specific plants while keeping the rest on the system. Water culture is capable of an awesome crop production when designed and maintained correctly. As with most any grow technique, you will want to do your homework first, and then carefully design and plan your system and your protocol for plant care. As each crop matures, always take notes to make future crops even better and your success more certain.